Chapter 4, Lesson 4 of Pre-Calculus, and we want to continue our look at the sinusoids. We looked in the last video where we have a value of a in front of the function, which we learn is simply a vertical or stretch or shrink, which we've been doing so far. But when we're talking about sinusoids, we're going to use the word amplitude instead of vertical stretch or shrink, but it is still the same transformation of the function. It still is a vertical stretch or a shrink. We learned that we can calculate this value by taking the maximum value of the wave, or the highest point, subtracting the minimum value or the lowest point, dividing by 2, and that gives me the a value, which we then see in the front of the equation as we're looking at it. In this video, we want to look at a horizontal stretch or shrink. Horizontal stretch or shrink. And the horizontal stretch or shrink is going to affect what we call the period of the function. Okay, so let's take a look at that, what the period is here, so we have an idea. You remember when we looked at the sine wave again, that we start at 0, and let's say we'll just have the normal sine wave. So it reaches its maximum point at pi over 2, then 0, then its minimum point 3 pi over 2 here. And so this graph is a nice, come on, I gotta do better than that. Alright, so this graph is alright, I'm gonna do this one more time. If not, then I'm gonna shut the video off, do it, then come back and show you. See if I can't do it live here. Okay, that's not bad. Alright, so you can see the amplitude is 1. Now, the period is the time that it takes to make one full cycle. Okay? So that's the definition of the period, is the time that it takes for it to make one full cycle. Now, the time that it takes is a horizontal measurement. So what I want to know is, how far is it from where it begins at 0, it goes through its whole cycle, reaching its max, down to its min, and then gets back to 0. What is this distance from here to here? That is the period. So the period is this horizontal length, the time that it takes, or the number of angles that it takes, or how long it takes to go around the circle. All right, that's the period. Okay, now normally the period of the sine function of these sinusoids, the period is 2 pi. That's the normal period of the sine and cosine function. It takes once around the circle, 2 pi, in order for both functions to start at 0, go to max, back to 0, go to min, back to 0. You remember the cosine was max, 0, min, 0, max, but the period is the same. Okay? So the period is 2 pi. So when we're talking about a horizontal stretch or shrink, we're talking about making this where it completes this cycle, max, min, maybe in a shorter amount of time, squishing it together, a horizontal shrink. Or maybe we stretch it out so it doesn't reach its max to way over here at pi, and then back to here, and then it's got to go way out here to all the way out to 4 pi or something before it completes its full cycle. That would be a horizontal stretch. That's stretching it out. So a horizontal stretch or shrink is going to affect the period of the function. Okay? And again, the period is the time that it takes to make one full cycle. All right? So let's take a look at that, where that's going to show up in the equation then. If we go back to our equation, where is the period? Well, the period does not fit directly into the function. All right, we have to calculate, well, let me change this, calculate what we call the b value. All right, so I'm going to write this now. So we have our amplitude, sine, and b is going to be next to theta, b theta. All right, so b is the value that is not the period, but affects the period. This is the vertical stretch, horizontal stretch or shrink. Okay, this is the stretch or shrink, that is the b value. And just like when we substitute it into another equation, the b value is going the stretch or shrink is going to be the reciprocal of what we see. Okay? In other words, if I have, let's say, y equals sine of 3 theta. This is a 3. The horizontal effect is going to be the reciprocal of this 3. So it's going to be a horizontal effect of 1/3. And because it's a third, that's a number between 0 and 1, this is a shrink. So this b value, this horizontal stretch or shrink, in this case is a shrink of 1/3. It's the reciprocal of what I see. If I had y equals sine, let's say, of 1/4 theta, I see 1/4, I take the reciprocal, which is a 4. That number is bigger than 1, so this is a horizontal stretch of 4. So the value that I see next to the theta, or next to the x value, because remember, this is the input. Theta is just the Greek letter for degrees, which means this is where the angle measure goes in, and those are on the x-axis. So these are essentially the x values, the input values. The horizontal stretch or shrink is the reciprocal of the number that I see here, and this number is the b. Okay, so that's what goes there. Now, let's tie that together with the period, okay, because that is not the period. B is not the period. B is the stretch or shrink. So we know that it affects the period, so how do we calculate the period? The period is then 2 pi, which is its normal cycle, divided by this b value, okay? You take that normal 2 pi cycle that it takes and you divide it by the b value. That is going to then calculate for you the period. So I need you to remember this little equation. Okay? The period is equal to 2 pi over b. All right? The b value is the number that you see here. Okay? So you take 2 pi, you divide by that number, that gives you the period. That gives you how long it will take the function to complete one full cycle. Okay? Very important equation to remember. Just like we had to remember this for the A, we must remember this for the B. Now again, I'm going to give you one example of how we calculate the period so you can see, and then we'll talk about a couple more things in a couple more videos, and then I'll tie all of these things together in one video and do a number of graphs so you can see how this all works. But let's take one equation. Let's say I have the example I just used, y is equal to the sine of 3 theta. What is the period? Well, the period is equal to 2 pi divided by this b value, 3. So the period is 2 pi over 3. So what that means is rather than taking 2 pi to complete its cycle, if you took 2 pi and divided it into 3 equal parts, let's say here, normally the sine function would take this long to make its cycle. But this 3, and again, this is going to be a shrink of 1/3. That means it's going to take less time. And 2 pi over 3, if I took 2 pi, divided it into 3, the sine function then is going to repeat or complete its full cycle in just that 2 pi over 3 amount of time rather than the entire 2 pi. So you can see that this shrinks the period by a factor of 1/3. Okay? So I know that's kind of quick and kind of maybe a lot of information in one video, but I'm going to end it right there, and then in the next video we'll talk about how that affects a horizontal shift. We'll look at vertical shifts in the next video, and then again in the one final video we'll tie all of these values together so you can see how they work together.